Welcome back to the channel. I'm Xavier Smith, and today I'm going to teach you the unit circle. So, this is a lot. This took me a long time to draw, and it would take a long time to memorize everything on here. So, all you really need to memorize is this first little quadrant: 15, 30, 45, 60, and 75. So, let's get started. 15 degrees. This is the odd one out, 15 and 75. These are the odd ones out. So you can't use a special right triangle to find 15. So you're just going to have to memorize it. 15 degrees is 0.97, comma, 0.26. That's all you have to memorize. Don't even memorize 75, because 75 is just the flip. 0.26, comma, 0.97. So when you have two complementary angles and they're put into opposite functions, they're congruent. That might also seem complicated. So, quick example, 30 degrees. Let's use sine 30 degrees is 1 over 2. Then cosine 60 degrees, which is its complement, is 1 over 2. So that would mean 15 is 0.97, comma, 0.26. So 75 is 0.26, comma, 0.97. 30 degrees. Well, we can make our 30, 60, 90 triangle. 30 degrees. It goes cosine, then sine. So x is cosine, y is sine. So cosine is the distance over, sine is the height. So 30 degrees. We put it in our 30, 60, 90 right triangle. First, we find cosine. Cosine is adjacent over hypotenuse, root 3 over 2. Good, root 3 over 2. Then sine, 1 over 2. Root 3 over 2, 1 over 2. And we can already say, well, that means 60 degrees is 1 over 2, comma, root 3 over 2. Great. So 45 degrees. Now we make our 45, 45, 90 right triangle. Remember your property, 1, 1, root 2. Because in the unit circle, the radius is 1. So all these x's just go straight to 1. Now, sine of 45 is 1 over root 2. So we have 1 over root 2. But you can't leave it like that. It's just not simplified. You have to rationalize it by multiplying by root 2 over root 2. It's the same thing as multiplying by 1, so it keeps the equation the same. And that is root 2 over 2. I know, a little annoying that it's got an extra step there, but it's got to be done to simplify it. So root 2 over 2, then cosine, 1 over root 2. Oh, that's also root 2 over 2. So 45 degrees is easy. Root 2 over 2, comma, root 2 over 2. 75 degrees? Well, it's the same thing as 15, but flipped, because they're complementary. So it's 0.26, comma, 0.97. I know, a lot to memorize, but just remember this 15 is 0.97, comma, 0.26. Then we get to 90 degrees, which 90 degrees is straight up, and that is 0, comma, 1. You're just on the x-axis, top of the unit circle. 0, 1. Then we go to 7 pi over 12. Well, what is this the same as? 7 pi over 12 is the same thing as 5 pi over 12, but the signs change. So here in this quadrant, the x's are negative and the y's are positive. So it's negative, positive. Over here it's positive, positive. Over here it's positive, negative. And over here it's negative, negative. Just if you're thinking of a graph, these are negatives, these are positive y's, these are positive x's, these are positive y's, these are negative y's. So just think of that sine cosine. What we're saying here is 5 pi over 12 is 5 pi away from 0. Well, 5 pi over 12 away from 0. And what this is called is a reference angle. Every angle in this first quadrant is a reference angle to another 3 angles. So this 5 pi over 12, we're going to do, well, 5 pi over 12 is your reference angle. Here, if you're in the second quadrant, it is 180 minus 75 degrees gives you your reference angle, which is 105 degrees. But we are going to turn this into radians right here, right now. So 0 degrees and 360 degrees is 0 pi radians and 2 pi radians. So a whole circle is 2 pi. That means half a circle, 180 is pi. 90 degrees, a quarter of a circle, is pi over 2. And then 3/4 of a circle is 3 pi over 2. Getting that straight. Now, when we're finding a reference angle, we have 5 pi over 12 as 75 degrees. This is pi. First, we're going to get the common denominators. Pi is equal to 12 pi over 12 pi. And then what we're going to do is we're going to do 12 pi over 12 minus this reference angle. So 12 pi over 12 minus 5 pi over 12 gives you 7 pi over 12. So that gives us a reference angle in the second quadrant. Well, then how do we do it in the third quadrant? We do pi plus the reference angle. So pi plus 5 pi over 12, which is 12 pi over 12 plus 5 pi over 12, which gives us 17 pi over 12. How do we do it in the fourth quadrant? Well, we do 2 pi minus this reference angle. So 2 pi minus 5 pi over 12 is equal to 24 pi over 12 minus 5 pi over 12 gives us 19 pi over 12. So that is a lot. What am I saying? This first quadrant is your reference angle. This second quadrant is pi minus your reference angle, and you'll get the minus your angle in here will give you one of these angles, which has the same measurements. Then third quadrant is pi plus this reference angle. Fourth quadrant is 2 pi minus this reference angle. So it is a lot. But let's keep going. So we already discussed our reference angles. Now, 2 pi over 3, well, that's the same thing as pi over 3. So pi minus pi over 3 is 2 pi over 3. So that's the same thing as our 60 degrees here. But pi over 3 is 1/2, comma, root 3 over 2. And then that means in the second quadrant, where the cosines are negative, we have negative 1/2, comma, root 3 over 2. Then 3 pi over 4. Well, that's the same thing as pi over 4. So pi minus pi over 4 equals 3 pi over 4. And where the cosines are negative, again, we get negative root 2 over 2, comma, root 2 over 2. And we keep doing this over and over again. So let's do 5 pi over 6. Well, I already know the reference angle there is pi over 6. Yes, because I can do pi minus pi over 6 and get 5 pi over 6. Well, pi over 6, what is it? Well, it's root 3/2, comma, 1/2. So here it's negative root 3/2, comma, 1/2. We do it again. This is 11 pi over 12. Well, that reference angle is pi over 12. What's pi over 12? Well, it's 0.97, comma, 0.26. So over here in the second quadrant, 11 pi over 12 is negative 0.97, comma, 0.26. Then we get to 180 degrees, which is pi. It is half a circle. A circle is 2 pi. This is pi. Pi is negative 1, comma, 0. It's on the end. We keep doing what we did in the second quadrant, but now we do pi plus this reference angle, and then both cosine and sine are negative. Then we get down to 270 degrees, which is 3 pi over 2. And what do we do? Well, it's 0, comma, negative 1, so I have to find the cosine or sine of 3 pi over 2. Oh, you got it right there. Then we go to fourth quadrant. What do we do to get answers in the fourth quadrant? Well, we do 2 pi minus this reference angle in the first quadrant. It will give us our pi radians in this quadrant. And then we take this angle, this measurement here, from the reference angle, and we turn the cosine positive and the sine negative. So that's all we do every time we go back to this first quadrant. Here, the cosine will be negative and the sine will be positive. Here, cosine and sine are both negative. Excuse me. Fourth quadrant, well, the cosine's positive and the sine is negative. So what do? We're always going back to pi over 12, pi over 6, pi over 4, pi over 3, 5 pi over 12, and pi over 2. That's all we're doing. We're always going back to this first quadrant. So what are we doing here? Well, we're adding 15 every angle in this first quadrant and on. So it's 15, 30, 45, 60, 75, 90. If you forget how to do that in radians, if you forget like 30, well, what you do is you add pi over 12 for each 15 degrees. So 15 is pi over 12, then 30 is 2 pi over 12, which is pi over 6. Then 45 is 3 pi over 12, which is pi over 4. And so on. And we keep doing this over and over again. If you forget your, like, what's cosine of 60 degrees? Well, if you don't remember it's 1/2, make your special right triangle. I tell you, the only thing you really have to know, well, memorize, is 15 degrees is 0.97, 0.26. All you have to know. And then all you know is this first quadrant, and then just find your reference angles. So going over it one more time, this first quadrant is your reference angles. Know these, use your special right triangles, know 0.97, 0.26, and 0.26, 0.97. Remember, complementary angles put into opposite functions are congruent. So cosine of 60 degrees equals sine of 30 degrees. And then, second quadrant, what you're going to do is you're going to do pi minus your reference angle. And then you'll get this number, whatever it is. And then you change the cosine negative and the sine positive. Third quadrant, you do pi plus your reference angle. And you'll get whatever it is. Then cosine negative, sine negative. Fourth quadrant, do 2 pi minus your reference angle, and then do cosine positive, sine negative. And you'll always know what function this goes, what reference angle this goes back to. So if you're told, find 7 pi over 6, well, you have to think, okay, well, 7 pi over 6, you see pi over 6 here. That's the key one. Pi over 6. Oh, go back to pi over 6. Root 3 over 2, comma 1/2. And then you're, negative root 3 over 2, comma negative 1/2. Do it again. Okay, 17 pi over 12. Well, I see pi over 12 there. What's pi over 12? Well, it's 0.97, comma 0.26. So it's negative 0.97, comma negative 0.26 because you're in the third quadrant. You get 3 pi over 4. Well, I see pi over 4. 3 pi over 4 I know is 3/4 pi, so I know I'm in the second quadrant because that's between pi and pi over 2. So 3 pi over 4, well, pi over 4, go back to root 2, comma, root 2, and that root 2 over 2, comma, root 2 over 2, cosine negative, sine positive. Do it. So negative root 2 over 2, comma, root 2 over 2. Do that over and over again. Use your special right triangles. Remember, 0.97, comma 0.26 is 15 degrees, and then 75 degrees is 0.26, comma 0.97, because the complementary angles, can't say this enough, complementary angles put into opposite functions are congruent. and then remember your reference angles, please. Thank you very much. That was a lot. Let me know if you need another video on it. Thank you for watching.